gentlemen, good morning and welcome. We're going to try this out for today, see how it goes. If it goes well, we'll move into this going forward for the foreseeable future. So what we're going to try and do today is we're going to try and talk about a new topic. Way I'm going to try and structure today's lesson is a short video or two. We'll see if I want to break this up into one or two yet, but short 5-minute videos. I'll have them posted. They'll be on YouTube. They'll be posted via the Google Classroom, and then we'll have some questions for you to work on. Okay, but what we're going to be talking about today, what you're seeing in front of you is the reference sheet, and this is the reference sheet that we use for Algebra 1, Geometry, and Algebra 2, so it's the same unit sheet. Now, we never really talk about the top part of the unit sheet, of the reference sheet, and the reason for that is it's not really specific to any one class. This top part is just a bunch of conversions. It's going to happen. There's going to be a conversion problem in geometry. There's one every year on all the tests. Something where you're going to need to convert units. We can talk about that at a later date. They may come up here. We'll have to see. But what we're really looking at today is the entire left side of our formula sheet. So the left side of our formula sheet here gives us triangle, parallelogram, circle, area formulas. Okay, so we get some area formulas, and then for a circle, they also give us two different formulas for circumference. So that would be pi times the diameter, or you could find the circumference as 2 pi r. What's new, and we're going to be specifically looking at, is volume. Okay, so area is a 2-dimensional measurement, volume is a 3-dimensional measurement. Okay, it's how much space something occupies. So we're going to talk about general Prism's volume, V equals BH with a capital B. We'll explain what that means. We're going to look at cylinders, okay, V equals pi r squared H. We're going to look at spheres, V equals 4/3 pi r cubed. We're going to look at cone, V equals 1/3 pi r squared H. And we're going to look at pyramid, V equals 1/3 base times height. We're going to start with the cylinder, okay? Actually, we'll start with the cylinder. We can start with the cylinder. So we've got our cylinder. And for those of you that are not familiar with a cylinder, I always equate it to like a can of soup. So we've got our cylinder there, and okay, that's what it looks like. And what I need you to understand about a cylinder is just a circle that has been basically brought up and down. Okay, so we look at the top part, and the top part is a circle with a radius. Okay, that radius r. Now, the volume formula for a cylinder is pi r squared h, okay? And so we need to see how we can use that. Well, we know that our circle up here at the top has a radius, and we know that we have a height, okay? Our cylinder is so tall. Pi, if you remember, we used 3.14, but we're really just going to either leave it in terms of pi, or we're going to plug the pi button into our calculator, okay? And there's a number of calculator apps that we can use to do that, right? So that we can deal with the pi. And so while we're here working remotely, if you don't have your TI-84, you can look back at the Google Classroom. We've talked about a few different ways to download a calculator app so that you can use it during this time. Okay, so let's look at an example here. Let's say that we have a cylinder, okay, and let's give it some numbers. Again, these drawings will get better as we go. So we've got a radius of 3 and a height of 6. So for our example here, we know that the radius is equal to 3. We know that our height is equal to 6. So if we're asked for the volume, it's going to be pi. We're going to multiply the radius squared, right? So for us, that radius is going to be 3 squared, and we're going to multiply that by 6. So two different ways to do this. The first way that I'm going to show you is how to leave this in terms of pi. Okay, so to leave this in terms of pi, we're going to be doing just the numbers. We're going to leave pi in our answer. So 3 squared is 9. 9 times 6 is 54. So we end up with 54, and then we just tack on that pi. So volume is 54 pi. Now, if you needed to plug this into your calculator, what you're going to do is simply just plug in 54 pi, okay, and what you get out of your calculator is 169.6460033, and we run out of space on the page. So if we had to round, we're going to round this, let's say, to the nearest hundredth, 169.65, okay? So either one of these answers is going to be accepted, and we'll see different scenarios depending on if they say in terms of pi or not, as to whether we're actually going to leave it in terms of pi. Okay, so again, something to kind of think about there. All right, the next shape we're going to look at is a rectangular prism. Okay, so for the rectangular prism, we don't actually see that listed anywhere on our sheet. The rectangular prism is going to be under general prisms. Okay, so for the volume of any general prism, it is capital B times H. So let's look at what a rectangular prism looks like. So a rectangular prism is a rectangle, okay, and it's going to have some three-dimensional shape to it. So we have, and I'm going to draw in the hidden lines here just so you can see them. Okay, these dashed lines represent the hidden lines of our rectangular prism, but we have this 3D box here. And again, it's a three-dimensional shape. Now, the capital B for any, for any general prism, the capital B is equal to the area of the base. So instead of giving you a different formula for triangular prism, rectangular prism, if you had like a pentagonal prism, anything like that, what they're going to instead do is just give you the general prism formula, and then you've got to use the capital B to find the area of the base. So if we look at an example here, if we take a rectangular prism and we add some numbers to it, okay, sometimes those hidden lines will be drawn, sometimes they won't. But let's say that we're looking at this here and we know that the height here is 3. We know that the width here is 7. And let's say that we have a height this way of 10. So the base is going to be this part here. Okay, this is how we're going to look at this. So this is going to be our base. So the first thing that we need to do is we need to calculate the area of the base. So B is going to be the area of the base. The base is a rectangle, meaning that our area is just length times width. So for us here, our base is just 3 times 7, which is 21. Okay, now we're going to plug in to find our volume. Okay, so finding our volume here, we've got volume is B times H. Okay, our H is this 10 here, so our volume is going to be 21 times 10. Our volume is going to be 210. Okay, now one thing we really haven't talked about is units, and none of these problems have had units yet, but it's going to be units cubed. Okay, so just like when you think about if you were going to order a rug or, flooring, it would be square footage, right? If you were going to order fence, it would just be feet, like I need 300 feet of fence. But for area, you're going to need a two-dimensional measurement. And for volume, right, how much water do you need to fill up the pool, you're going to need a three-dimensional unit. Okay, so for that, that's going to give us rectangular prisms. Okay. We're going to stop now, break this up, and we'll start a new video where we talk about triangular prisms. We're going to talk about the sphere, and then we'll probably use a separate video for cone and period.